Did you ever wonder how to move the procedure?
We are recording.
Refactoring procedural.
No?
Ever wondered how to refactor procedural code into an aggregate? Lucky you, lucky that you're here, because today that's what we are going to do. It will not be step by step, we'll just show you solution 1 and solution 2, but we'll go through the solution number 2, just so you understand why it has been made that way. This will be very simple implementation without any additional refactoring, just a minimum code that will work and that will allow you to refactor your model that is anemic into an aggregate. And today, of course, we're here with Tomek. Hey, Tomek.
Hi. I will add that it was also the idea for the episode was also because of your comments on the YouTube and LinkedIn. So please comment and we will record new episodes based on what you want to hear from us.
Yes.
Yeah.
There may be a little bit of the delay, but we'll do our best to do it ASAP, as fast as ASAP. Okay, so we are back to our task model. You probably remember from previous episodes that I will link somewhere here. Thanks for the feedback about that, by the way, as well. And our task is very simple model. As you remember, we are able to create task, change its name, assign some date that when the task needs to be finished. We have the complete method, which completes the task, reopen, and deleting task, right? So there are some simple rules as well, right? For example, the task can be only completed if it's opened. It cannot be completed, for example, if it's deleted. And
so
there is,
it's basically about the state, right? The change, state change here. So we can go from one to another and so on. And when we delete, we cannot do anything with the task anymore, right? At least
that's
for
true.
now.
At least for now. And in certain states, you can do some methods. For example, when the task is open, you can rename this task. So that's just a quick reminder. There's another video about that as well. I mean, not the task specifically, but how we got into the current solution, which I think we should show right now.
One more thing. As Łukasz mentioned, it's just some kind of simplified model. But again, if you have any ideas that you would like to, you would like us to model here, add some requirements that are interesting, we can do it, and probably we also will do, right? We would like to add one more thing in some of the next episodes where we extend this model, but it's always good to have some kind of feedback from you. What would you like to see here? So we can use even the simple model that you know already from our videos, and we can extend it. But let's get to the code now. To the old version of the code, actually, where we had this task service and the methods to the task model, very simple task model here, right?
Yeah, that's a very simple implementation. There was no aggregate, and it may be very familiar to you that the task class itself, it looks a little bit like an active record. It doesn't really. It has some methods which modify the state, but that's not really a lot of it. We have this apply method that helps us to build the state whenever the task object is retrieved from the event store. And in the task service is where the logic was executed. But now we want to do it differently. Tomek, what are we going to do?
So, because this model is like anemic, right? It has no business rules inside any method, so it actually accepts everything what it gets from the higher level, and all the rules are placed in the service methods. And we don't like it. We would actually like to encapsulate the logic inside the task model. And if we have some kind of business rules that we want to encapsulate in the task model together with some data, we are thinking about something like aggregate, right?
Yes, and I'll just add one more thing. When this is problematic that we have this business logic which is not encapsulated, this may be problematic when your friend Staszek will just take this part of the code. He will maybe just modify the service duplicate the service, or he will not be even aware that there is such a thing as a task service, and he will create his own, and then he will reinvent the rules of, for example, changing the name, right? And as you can see in this line number 12, you cannot change the name unless the status of this task is open, right? That's our business. That's how we structured. That's how the business is structured. And the problem which this leads to is that we will have the data in the database that shouldn't get there. And everyone and each of you who has worked in production, you know that whenever you run into this situation, I mean, it costs a lot of time, right? To make it right, you need to write some scripts, you need to migrate this data, and so on and so forth. So we don't want that. So that's why we are using encapsulation, so we don't have to reinvent the wheel every time we need to do something with our task object. We want to have this centralized.
Yeah, I actually like the point you mentioned here, that if we have like another service and we just change the name, we can do it and we can skip actually this rule, right? Which is extremely important for business. Probably.
Hopefully.
Hopefully,
yeah. So that's the point. And maybe it's also a good moment to just say what the aggregate is, because we have agreement on that in Arkansas that the aggregate name is maybe not the best one. As the pattern itself, but what aggregate, according to our definition, is encapsulation of the business behaviors inside of one class. So it's not, and this class only has whatever it needs to make those decisions. So for example, it's not about aggregating data. So we're not aggregating task name, assigned data, and so on, because people sometimes think that, okay, it's aggregate, so it needs to aggregate something. It's more like aggregating or encapsulating the behaviors and the data that changes together in one place. So you can think about the aggregate as something that should always change together. We should always change the status and the name, because then we can ensure in one database transaction, or just atomically, that the name doesn't change without the status, because it may get into state that is not acceptable for our system.
Yeah, I think it's also sometimes it's like we might have like idea to put more and more data into one model, but actually we should think whether actually the data that we want to add, whether they are connected with any business rules. So it's not, maybe not in this case, because in this case we actually have the name, and when we, for example, assign the date, we check whether it's open, right? So always when we assign the date, we check whether the task is open. But I can imagine a situation where we actually don't care about any rule. And then...
For example, in Trello.
In Trello, exactly. And then maybe the date itself is not a part of this model anymore, right? Because it's only just for some kind of read part or something like that, right? Because it's not connected with any business rule. So when you model the aggregate, you also have to think whether the data that you want to add to the model, whether it is connected with any business rules in the scope, let's say, of this model, right?
And what Tomek described is what is often called like high cohesion. So anything that is in the class, it should be related to one small task or set of tasks in this case that should work together. Okay, but show me the code.
New code, right?
New code. So you're familiar with this one already. You can go to previous episode to get some more details, why it is structured that way. But right now we will show you the new way, refactor to aggregate. Maybe let's skip the create task, Tomek, for now. As I think it's the most interesting. So you have to watch longer if you want to see that.
Nice one. Okay, so before we go into the code, I would just like to show you tests. So what's interesting here, we didn't change them at all, right? We can, I think it's safe to compare those changes, right?
Yeah, so the last changes you can see was in March, because that was one of the requirements that we took for this episode. We decided to refactor this class, and as you know, refactoring is changing the structure of the code without changing the observable behavior, right? So that's what we did. The behavior didn't change. This is confirmed by the tests. But also we didn't want to change the interface of the task service because it may be called in the many places. As you can see, tests are still green, and therefore we achieved our goal. Thank you for watching.
So now,
just kidding.
Nothing changed here.
Please stay.
No, we can finish the episode like
Got
that.
it.
But then there were some changes in the task service, right?
Yeah. So previously you probably know the find task method that we used to read all the events and apply them manually. Now it's changed, right?
Yeah, we are using our RailsEventStore gem here, right?
Yeah, it's called Aggregate Root. We'll get into that when we go to the task class. What you need to know for now, it just exposes a repository that we are using right here. What we do here is that we create a new object. We specify a stream name, so from which stream it should read the events. What we said about streams in previous episode, which also should be linked. I think this episode will be most linked at all from the ones that we made. Anyway, it creates the object. It takes the object and then applies events to this object. And then we can, for example, call the change name method on the object itself. And then after, just if we finish this flow, we store this task, this object task, in the same stream. And shortly, what the store does, can you move to implementation, Tomek? Yeah. So what it does, it just takes the unpublished events from the aggregate. As you can see, it's an array, and then it publishes it into the specific stream. And also there is something called expected version, but I think expected version deserves its own episode. There's a lot of things you can do with expected version. It's really amazing and important. For now, if you're curious, refer to documentation because it's very, very well described in here.
And as you can see, it's like from the module aggregate root from our gem, right? So we do some kind of magic for you. It's not, as we said, it's not a big deal, not a big magic here. It's just some kind of helper for you, so you don't have to care about internals too much, right?
Yeah, you can write it on your own, but to be honest, I don't see a need. Although, if you decide not to use some gem, I respect your decision. I always pick the gems into my gem file very carefully. So if you don't need it, of course, you shouldn't bother to include it. Okay, so the difference you can see right now is that the rules have disappeared from here, right? We don't see these if statements anymore in here because they were moved to the task. So as you can see, the rules have been moved in here. So for example, when we change the name, we won't do this when the status is not open. So that's the logic that we had previously as well. So all we did, we just moved it from the service into the class. But we also did one more thing. If you could scroll up, Tomek, we included this aggregate root. And what it does, first of all, we already used a repository from the aggregate root module, right? We did it in the task service. But also what it gives us is two methods. One is the apply method, which applies the event into the unpublished events. You can see that, of course, it's open source. You can take a look at the GitHub. But what it does, it just applies the events into unpublished events and applies the strategy. We'll not go into that right now. We'll talk about that in the other episode, I think, internals of this, how it works and why it's structured like that. And besides that, it also gives you this on method, which is that's interesting. This is DSL. As I said, let's not get into the details right now, but we can take a look at how this is used. And the way we use it, we just specify that what we should do on a certain event. So for example, on task created, what we do, we get the ID. Although I would argue if this is completely necessary.
We don't need it because we do it when we initialize the object actually. Yeah.
Yes, and this information is in the stream as well. Okay. What we do here, we assign the status to open, and as you can see for the another events, we basically do the same thing as we did in the apply method, so there is not much change. However, we had to extract it to this on DSL. So what it gives us when the repository calls load, so it takes the events, then it goes through these on methods, right, depending on type of the event, and then it applies methods, and then we have our new state. And in that state, we are executing another method. So we send another signal to our object, and then the object, based on its internal state, decides whether it can perform the operation or not. That's more or less what happens.
And I think we can add one more thing here, which is actually interesting as well, that usually when you think about executing methods on some kind of models, you change the state in the method, right? But we actually do it when we handle the event, because events are like facts in our system. We know that something happened and it happened for sure. So we don't do it when we, let's say, execute the method, but we change the state when we apply the specific event, right? To the model.
Okay, and now I think we can go back to the create. I said we will skip it, and now it's the interesting part. Because as you can see
here to the service, right? Okay.
Yeah, we can start from the service. So you scroll up.
I mean the create task. Yeah.
You see, creating tasks is a little bit more complicated than the rest. Tomek, do you want to explain why this happened? Because we had really nice discussion before we prepared this example.
Yeah, because you can think about like creating some kind of new instances of the class. That you do it when you create when you call the initialization, but actually you have to split those two things, right? So one thing is creating the instance itself, but the other thing is like calling the business method that is important for business, which tells that some kind of task was created. So we have to decouple those two things from each other, right? So you initialize the object, like you initialize it when you read it from the repository. You initialize the task, but you do not create it at this specific moment, right? For you, the important thing is that when you call the specific create method, you know from the business perspective that now your task is like a task that can be managed in your system. And this method actually publish task created event, right? You can also think about it like it's like preparing the object for coming, operations. So for example, because here we only have UUID, like here as well, task ID. But you could also inject some kind of policies or that the model itself will use in the future, or for example the clock. I mean the time service or whatever you call it, right? So you can, for example, in the tests you can pass some kind of different implementations. Would you like to add anything, Łukasz, here?
No, not from the create perspective. No, just one more thing regarding just this approach. So as you saw, step by step, what we did, we moved the logic from the service into the task class. This gives us possibility to reuse this task class in other places, in other services, or in other processes, whatever you call it. Besides that, it looks like we should probably move some of the tests to our task class. So we would probably create a task test normally. Of course, what would be the best approach would be to do it in the TDD way. So first write a test before implementation, but in this case we had some tests that actually helped us verify if our refactoring was successful. Now, I would probably move some of those tests, or actually maybe all of them, and then only support some other cases in the upper layer. And for the task class, I would aim in having 100% of mutant coverage, just to make sure that there is no unexpected behavior from this class, and that whenever there is some change that we will discover it, if the change is unnecessary and will break the model in an unexpected way.
Exactly, but at least we have this safety net, right, in the form of the task service test that will catch whether our refactorings are fine, right? And
yeah,
we can in the meantime we can add the tests for the task model itself.
Yeah, of course. Yes, this is not a production project. We just wanted to show you how you can go from this task model that was not so perfect and in the task service into some other model, which is the aggregate root, which implements this and which knows inside how to apply those events and how you can use this together with the aggregate root repository and the aggregate root module itself that we also include in the task class. And I guess that's it for today.
Yeah, and we had 2 episodes that were below 15 minutes, and now we have almost half an hour.
Doesn't matter.
No.
You better get a larger lunch before watching that, although I say it after you watch it, hopefully. All right, so see you next time.
See you. Bye.